The D-Model application is composed of several steps. First of all, we will train the model in the Mare Nostrum supercomputer using PyCombs and DSLib. Then the model will be saved to a binary file to be packaged in a container, then uploaded to OSCAR. Then we will see in OSCAR how we will trigger the inference process also with COMBS, uploading a random file in the Minio storage. So this file represents fresh data coming from the patient device, and through this upload OSCAR will instantiate the inference process. So let's start with the first part. So we are in the Mare Nostrum supercomputer. We run the training. First we run the script to enqueue the job in the Mare Nostrum queue. This application developed with PyCombs uses then the DSLib library, instantiate a Cascades SVM algorithm to train the model using the training set, and the model will be trained and saved to a binary file, as I said. Also, we'll have the score of the trained model calculated at the end. We will see that, so the job is already enqueued. We can check it that is running. So here the COMBS runtime is starting and will be ready to a few seconds to process the data. This process will last around 8 minutes, so in line with the constraints that I showed before in the slide, where we had the time constraint that can be used by the user. So in the meantime, we can have a look at previously executed model, and we will see here that the model ended in almost 400 seconds, producing also a score of 0.78. We have to remember that the final score is the average of that we calculated is the average of several training, of course. So once this process finish, we have the model saved in a binary file. So we package this model together with the application in a container that has been uploaded to the OSCAR cluster. So we can see here that we have the services ready to be used. We have the DSLib CSVM container, and as I said, we have to upload in the proper storage an input file. So in this case is one of the files of the dataset that we will use randomly as new data to be trained. Of course, we have to put in the in part of the storage. So once these files are uploaded, we will see that the process will be automatically triggered by OSCAR. So here we can see in the logs that the file is uploaded, the input file is downloaded from the bucket, and that the DSLib inference process is also started. We can have a look in the meantime the result of a previous run, where we could see that the output of this prediction is a binary output saying that the classification returns 0, 1 depending on if it's a natural fibrillation or not. So this is the output that will be read by the user. You can see that probably this is going on. So the model is loaded and is running to process the result. Of course, in this case, we don't have any output, just a print it's a classification report that contains the value 0 or 1.